Okay, so reminder, this is gonna be what your assignment is on. So those of you who are not paying attention right now, make sure you are paying attention. 7.2. Okay, page 7. So x plus y equals 4. Okay, looking at this, it's not in slope-intercept form, so I have to rearrange it first. When I rearrange it, this is y equals negative x plus 4. So what's m and what's b? Y equals negative x plus 4. Eric? Perfect. Okay, so let's graph that line. And then let's say here. Okay, so first off, plot that 4 on my y-intercept. 1, 2, 3, 4. Put that point right there, and then slope is negative 1. So I'm gonna go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. I can keep going forever until I get a very nice line. Okay, so there's my first line. Now, if I know how to graph one line, can I graph two lines? Yes. Okay, so that's the purpose of today's lesson, is graphing two lines on one graph. Rearrange this equation. So I'm just following the same format that I did right here. I'm gonna move this x over, okay? But I don't want negative y equal, I want y equals. So I'm gonna divide everything by negative 1. So this becomes x plus 2, right? Moving the negative over by dividing everything by negative 1. So this becomes positive. This becomes positive as well. 2 negative make a positive. So m equals b equals. So coefficient, what does m equal? What does b equal? And b is? Right, so y-intercept is 2, and then my slope is 1 over 1, 1 over 1, 1 over 1, like that. So when I connect it, okay, my lines cross right here. Okay, this point right here, what is the intersection point? Derek?
1, 3.
1, 3. Whenever you talk about an intersection point, remember it's a point. So I should see two numbers, your coordinates. So it's not enough to say 1. It's not enough to say at 3. It's at coordinate 1, 3. Okay, so this point right here, that's where they cross. Okay, so today's lesson is really based on finding that intersection point. And then in word problems, what does that intersection point mean? So that's what the whole lesson today is about. So let's try this word problem. Ahmed wants to earn extra money selling orange juice in front of his house. It's going to cost him $2 to buy those oranges. And then each glass is going to cost 12 cents to make. Okay. He plans to sell the orange juice for 25 cents a cup. Write an equation that represents his costs. Okay, so his costs. I know some of you are already thinking about profit, how much he makes, and so forth. So looking at this, can I just say he's going to make 13 cents a cup? If it's going to cost him 12 cents to make and then he's selling it for 25 cents, can I just simply say he's going to make 13 cents a cup? No, because there was an additional cost that I have to divide up among all the cups that he sells. All right, so that's why it's not as simple as just subtracting it and then getting your profit. We have to do it step by step. Okay, so y equal, write the equation. Okay, so $2 to start his business. and then 12 cents to make. Okay, so can you put those two numbers in an equation, which we did like for like the 1,000 times? Uvin, do you have an idea? Y equals 0.12 x. Yeah, that's it. Okay. And then B, write an equation that represents his revenue. So again, revenue is not profit. Revenue is just simply how much he can bring in. Okay, he is selling it for 25 cents a cup. So what's my equation then? Y equals? Suhan for B. Write an equation to represent his revenue. So he's selling it for 25 cents a cup. Okay, or in this case, we could use decimals since there is a decimal in the question. So 0.25, but that's your cost, not revenue. So we took care of that too in this equation. This is simply just how much he can bring in. So 25 cents X per cup, right? Okay, so now we're going to graph both on the same graph. Should I do an L graph or T graph? Alex, can I sell -5 orange juice? No, okay, so I should do L graph. Okay, since I cannot unmake orange juices. Okay, what goes on the bottom? What's my independent variable here? Yeah.
Cups sold.
Yeah, cups. And what would this be? What would Y be? Dollars, money, cost. Okay, yeah. So I'll just say cost. Okay. So what is this point right here at the corner? 0, 0. So even if I'm not starting at 0, it has to be 0, 0. Okay. Now, if I do 0, 1, 2, 3, 4, 5, 6 like that, I'm going to get really small numbers like 12 cents, 24 cents, 36 cents, and that's going to look really ugly. Right. So instead of going by such small numbers, I could, for example, go by 4s, go by 5s, go by 10s, just to make it bigger. So let's say 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Okay. So my scale is up to me as long as I'm consistent with the scale. Okay. If you want, you could go by 2s. Okay, I'm optimistic in Ahmed's orange juice business that he can maybe sell up to 40. Okay, and then in terms of money, okay, this is where I'm gonna cheat a little. Okay, if he's able to sell 40, what's the cost gonna get up to? What's the revenue gonna get up to? So 25 cents times 40, that's $10. So I want to make sure I can at least go up to $10 here. So like maybe I go to go by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So all I did was I created a scale. Okay. So let's graph the blue line first. So blue line, if I can't sell any orange juice, how much will it still cost me? Yeah, $2 because I bought those oranges. All right, so right there. And then instead of thinking going up 1 over 12 up one or whatever, because of this scale that I have right now is not going by ones, and I don't see a rise over run. So instead, I could think, okay, what if I sell 12 cups? Right? So now it becomes like a table of value. So 12 cents times 12 cups plus 2 is going to cost me $3.44. So 12 cups is going to be around right here, 3.44. What if I do 20 cups? 12 cents times 20 cups plus 2 is going to cost me $4.40. Okay, what if I go 40? So 12 cents times 40 cups and then add on that $2 cost is going to cost me $6.80. Ooh, so I didn't do a very good job with the scale. I should have went by ones instead. All right, now my graph is going to look pretty small. It's okay. All right. So this is my costs line. Let's graph this now. All right. So let's say I started the business. I made a bunch of orange juice, but it's so sour that I cannot sell any. So how much money do I get if I can't sell any? Yeah. So there's 0, right? So this starts at 0, 0. Now, what if I'm able to sell 20 cups? So 25 cents times 20, I'm going to bring in $5. So 20 and 5. All right. What if I can sell 40 cups? Okay. 25 cents times 40, I'm going to bring in $10. 40 and 10. Okay. So I'm going to make this line right here. And this is my revenue. Okay. What does the point of intersection mean right here? So looking at this, I know I didn't do a very good scale. I should have went by ones instead. But looking at this, let's just say they intersect right here at that point. Okay, what's my intersection point? Derek? 10 looks like 16 to me. Okay, so Derek says 4 and 16. But what's his mistake there? Okay, it is a 4 and it is a 16, but what comes first? Yeah, X and then Y. 16, 4, not 4, 16. So 16, 4. Okay, what does this point represent? So on the assignment, I'm going to ask you, what does the point of intersection represent? Do not define for me that point of intersection is where the two lines cross. I'm talking about in terms of the question. Okay, I know what a point of intersection is. In terms of the context, good job. Okay. I love that explanation, but can you put in these numbers for me? So what does that 16 represent? 16 cups. And what does that 4 represent? Look at my y-axis. That's why at the beginning we labeled it. So what is the 4? What's the unit? Yen? Okay, and what's my unit then? Dollars. Perfect. Okay, So Derek put it in very good terms. He said, if Ahmed can sell 16 cups, then his break-even point is at $4. Okay. So part E, does Ahmed make a profit or lose money for selling 20 cups? So take a look at 20 cups right here. Who says he's losing money if he sells 20? Who says he's making money for selling 20? Good. Graphically, how do I know he's making money? Right. Okay. The red line is higher than the blue line, which means your revenue is higher than your costs. Okay. A little business right there. What if the orange juice is really bad and I can only sell 4 cups? So at 4 cups, who says I'm losing money? Yeah. Okay. Because your cost is higher than your revenue. Okay. So now let's say you're Ahmed's friend and he asks you, hey, should I continue my business? I put so much effort into this, or should I just quit? What would you say to him? What advice would you give Ahmed? Yeah. Add more sugar and chemical. Okay. But that's gonna be cost. Sugar is not cheap nowadays. Inflation, tariffs. Uh, so what more mathematical? More mathematical answer. I'm looking for a mathematical answer. Should I quit? Should I go on? Yeah, make it more expensive. Okay, so I like the thinking. You guys are thinking business wise. I'm thinking just pure math wise. Based on my equations, based on these numbers, based on this number. Claire, do you have an idea? Okay, so what's the key number of cups I have to sell? 16. So for this part right here, for the advice, and you better write this down. I'm going to be asking this on the assignment. You should have your 3-part answer. Okay, so if Ahmed sells less than 16 cups, what should he do? If he sells less than 16 cups, should he stay or quit? Quit, yeah, quit. Okay, what if he sells exactly 16 cups? If he can sell exactly 16 cup. Derek, what word did you say? Huh? The keyword? If he can sell exactly 16 cups? Break even. Excellent. So this is the break even point, which means he doesn't make money, he doesn't lose money, he just wasted his life. Which doesn't cost him anything. Okay. And what if he can sell more than 16 cups? If he can, he's very confident. So from now on, I'm gonna add in more sugar and use less oranges, so that I can sell more than 16 cups. People like drinking sugar water. All right, then he's gonna make a profit. All right, so all right, he's gonna make money. All right, so on the assignment, whoops, that's a dollar sign. It doesn't look like a dollar sign. On the assignment, it's gonna ask you what advice, what 3-part answer you should give, what advice you should give. So even though it makes sense, you're saying add more sugar, you're saying don't sell in front of a house. You can say like buy better oranges. These are business answers. I'm just purely looking for the math answer, which is this. Okay, based on the graph, what my break-even point is, Anything above my cost, that's a profit. Anything below the cost, that's going to be a loss. Okay. And in terms of the trend right here, the more cups I can sell. What's my trend? The more cups I can sell. Complete my sentence. The more cups I can sell. The more money you can make. Right. Alright. So what happens to the Y? Your margin right here is going to get bigger and bigger and bigger. Right? So the profit is going to grow. The bigger the profit. Awesome. Alright, so very important example right here. Make sure you understand this. Make sure you study this. It's going to be what your assignment is on. Okay. Last two right here, we're not going to solve. We're just setting it up. Rosa has $7.85 in dimes and quarters in her pockets. And there are 50 coins in total. So that's a big pocket of hers. Write the equation to solve this problem. Do not solve. Okay, so my two equations. What's my first equation? What's my second equation? I have 50 coins in total. Okay, who can come up with my first equation? I have 50 coins in total in dimes and quarters. Genevieve, you have any idea? Okay, so let's say instead of X and Y, we use D and Q for dimes and quarters. Okay, so number of dimes plus number of quarters. What does this equal? 50, yeah. Number of dimes plus number of quarters equals 50. So total number of coins. What about the second one? $7.85. This is the tricky one. Jason, can you help me with this one? Can I write my second equation for $7.85?
For $7.
Yeah, in dimes and quarters.
I actually don't know how to do it because I'm almost texting.
Okay. Oh, Derek.
We can make Q 2.5D, and then we do 0.1D.
Good. Good. Where did you get the 0.1 from?
Because the dime is 1 cent of dollar.
Right, dimes are 10 cents. And then quarters, as you said, are? Not 2.5. 2.5 would mean $2.50. So quarters are 0.25. Q. Okay, so 10 cents times the number of dimes plus 25 cents times the number of quarters, and it should give you a total of $7.85. Okay, so first equation is always the number of coins. Second equation is the value. In chapter 1 of grade 10, this is what you work on, and then you will solve it in grade 10. All right, so that's why this question, I don't need you to solve it. I just want you to know how to set it up. And then in grade 10, that's when you will actually solve it using different techniques. All right. Based on what we've learned in grade 9, can we solve it? Can we solve for the intersection point? What's the one method that we've learned so far in solving this? How did we solve this? Yeah.
The X and Y.
Okay, yeah. Or the intersection point based on our graph. So in grade 9, we can solve this, but we'll have to graph it. Okay. In grade 10, you will learn method of substitution, method of elimination. Have you guys heard of that? Yeah. So in grade 10, you will solve it mathematically. In grade 9, you'll solve it graphically. Okay, last example right here. These two lines cross at -1, -5. What's one way to solve? Okay, we just kind of talked about it. Do those two lines cross at -1, -5? What's one method? Vincent, any idea? Okay, I want to know if these two lines cross at this point. Uveen, let's say you're so stuck on the test or assignment. I want to know if these two lines cross, what can I do? I could graph it, right? That's basically the only way right now that we know how to solve it is graph it to see if it crosses there. But do you like graphing? No, it's time consuming. Right? So what we could do, since they did give us an answer, just like what we've been doing, this is my x value, this is my y value. So what I could do is sub it in. Y equals 3x minus 2. I could substitute it in. So y is -5 and x is -1. All right. If I substitute it in, what do I get? Left side is -5. Right side, 3 times -1 is -3. -3 minus 2, -5. Does left side equals right side? Yeah. So this is very important too. What does that imply? If this point satisfied this equation, it means it passes through the point. Excellent. So -1, -5 satisfies the equation, which means the point is on the line, or the line passes through the point. Okay. Now, is it enough to say that it's the intersection point then? No. For it to intersect, it means that it has to go through this line too. So we do it again with this equation. Y equals -x plus 2. Sub in -5. Sub in -1. All right, and I get -5 equals 3. Left side does not equals right side. All right. So if it equals, it means that the point is on the line. So if it doesn't equal, what does that mean? It's not on the line. So if it's on one line but not the other, can it be an intersection point? No. Okay, so therefore, no. -1, -5 is not an intersection point. Okay. So that's the lesson. I know I did longer than usual. It's about 30 minutes. But we did a lot of implying here. We analyzed it, a lot of problems, analyzed it, the equation, the graphs, and that's why this was an important lesson. And that's the purpose of learning math class, is to apply it and understand why you're doing this math. So this is a realistic math lesson in the future. when you get into like businesses, you're the consultant, you're gonna be graphing these type of graphs like every single day. Okay, because that's what they care about. They care about profit. They want to see what break-even point they need and so forth. So that's why we are having a assignment on Monday based on this. Okay, any questions? Okay, so to practice, oh look, instead of orange juice, he's selling lemonade. Okay, so very similar type of question that you'll see on the Monday's assignment. Who knows what I'm selling? Okay, so make sure you do try these. Try these. The answers are on page 10. Okay, any questions? Okay, good. So let's try it.